Welcome all to today's lecture. Myself, Assistant Professor Tukur Gupta from Ajay Kumar Garg Engineering College, Ghaziabad. I am covering Unit 2 now for Microprocessor and Microcontroller, KEC 502, which is being taught in 5th semester. So today I will be covering 8085 timing diagrams. What is timing diagram? It's a display of initiation of read or write and transfer of data operations under the control of three status signals. We have to notice this, that the control of three status signals, input, output, oblique memory, S1 and S0. All actions in the microprocessor are controlled by either leading or trailing edge of the clock. Yes. So clock is this way. Yes. So this is known as the leading edge and this is known as the trailing edge. Similar, another clock cycle and so on. What is machine cycle? So it is the time required by the microprocessor to complete the operation of accessing the memory devices or input-output devices. So in machine cycle, various operations like opcode fetch, memory read, memory write, input-output read, input-output write, these functions are performed. T-state. Each clock cycle is known as the T-state. So, this I have shown here. So, this is one T-state, this is another T-state. So, in this way, T-state is the basic unit, we can say. Each clock cycle is known as the T-state. Now, each machine cycle is composed of many clock cycles. Yes. So, what it wants to say is, suppose we are considering the opcode fetch machine cycle or memory read or memory write or input output read or input output write. So, these are the basic machine cycles. So, each machine cycle is composed of many clock cycles, or we can say many T states. Since the data and the instructions both are stored in the memory, the microprocessor performs fetch operation to read the instruction or data and execute the instruction. The three status signals, these are the status signals, these are generated at the beginning of each machine cycle. The unique combination of three status signals identify read or write operation and remain valid for the duration of the cycle. So, in this table, we can see these are the status signals and these are the control signals. So, and these are the variety of machine cycles which are used in the various operations. So, for the opcode fetch machine cycle, the combination goes like this. Input output oblique memory bar must be 0 because here memory is active low signal and for activating it we need to give 0. S1 is 1, S0 is 1. Read signal should be low, active low, because this is active low signal, so it should be 0. Write and interrupt acknowledge. So, in this way, similar to this combination, all other machine cycles are having the different combinations of status and control signals. Here, we can have a look, here Z and X. Yes. So, what are these? So, X means unspecified and Z means high impedance state. So, in this way, we can have different status and control signals for all the machine cycles available. So, this table shows this table, it shows the details of the unique combination of these status signals to identify different machine cycles. Thus, time taken by any microprocessor to execute one instruction is calculated in terms of clock period. As I told you, that one machine cycle is comprised of various T states, and one instruction is having a combination of machine cycles. So, as a conclusion, we can say the time taken by any microprocessor to execute one instruction is calculated in terms of clock period. The execution of instruction always requires read and write operations to transfer the data to or from the microprocessor and memory or input-output devices. So this is true that every instruction needs to fetch the opcode and needs to perform the read and the write operations either with the memory or the input-output devices. Each read and write operation constitutes one machine cycle as indicated in the figure below. Yes. So let's have a look on this figure. Various T states are shown here. State 1, state 2, state 3, 4, 5, 6 and 7. Yes. Suppose the one machine cycle is having 4 T states. So state 1, state 2, 3 and 4. This makes one machine cycle. And these 3 states makes another machine cycle. So each machine cycle is having a combination of T states, or we can say a combination of clock periods. This is the leading edge and this is the trailing edge. This is leading edge, this is trailing edge. This is leading edge, this is trailing edge. In this way the cycle goes on. So each machine cycle comprises of various clock periods or cycles, also known as the T states. What is the processor cycle? The functions of the microprocessor are divided into fetch and execute cycle of any instruction of a program. The program is nothing but the number of instructions stored in the memory in sequence. In normal process of operation, the microprocessor fetches. This is the first step. Microprocessor fetches the reads, or fetches means it receives or it reads the data, and that's the code from the memory, and executes one instruction at a time in the sequence until it executes the halt instruction. Now, instruction cycle is what? It is defined as the time required to fetch and execute an instruction. Yes. For executing any program, basically 2 steps are followed sequentially with the help of clocks. What are these 2 steps? Fetch and execute. Now, timing diagram. The time taken by the microprocessor in performing the fetch and execute operations are called fetch and execute cycle. We have already discussed. The sum of the fetch and execute cycle is called the instruction cycle. Yes. Each read or write operation constitutes a machine cycle. The instructions of 8085 requires 1 to 5 machine cycles containing 3 to 6 states. The first machine cycle of any instruction is always an opcode fetch. This we have to note that for every instruction, for any of the instruction, the first machine cycle in the timing diagram is always the opcode fetch. And in this cycle, the processor decides the nature of the instruction. It is of at least 4 states and it may goes up to 6 states in certain cases. Here we can understand this concept. One instruction cycle consists of fetch cycle and execute cycle. So suppose the fetch cycle consists of 4 T states, execute cycle consists of 3 T states. So this completes the instruction cycle. In total 7 T states. So this is the processor cycle. So how will you identify the number of machine cycles in an instruction? So here are certain rules which justifies all the cases. If an addressing mode is direct, immediate or implicit, then number of machine cycles is equal to the number of bytes. If the addressing mode is indirect, then number of machine cycles is equal to number of bytes plus 1. Plus 1. Then another case, add plus 1 to the number of machine cycles if it is memory read or write operation. If the operand is 8-bit or 16-bit address, then number of machine cycles is equal to number of bytes plus 1. These rules are applicable to almost 80% of the instructions of 8085. So first timing diagram that we are going to study is opcode fetch. So here are certain steps, a series of steps which we are going to follow. So we all know that opcode fetch operation requires minimum 4 clock cycles, T1, T2, T3, T4, and is the first machine cycle of every instruction. Yes, we know this. Suppose we are taking an example, fetch a byte 41H stored in the memory location 2105H. Now how will it proceed? For fetching a byte, the microprocessor must find out the memory location where it is stored. Yes. Then provide the condition for data flow from memory to the microprocessor. The process of data flow and timing diagram of fetch operation are shown in the figure. The microprocessor fetches opcode of the instruction from the memory as per the sequence shown here. So in the first step, a low input output oblique memory means microprocessor wants to communicate with the memory. Yes, because it is the memory part is active low. The microprocessor sends a high on the status signal indicating the fetch operation. So this is the second step. Yes, so a high signal is sent on the S1 and S0. So when both S1 and S0 are 1, it means opcode fetch machine cycle is going on. The microprocessor sends 16-bit address. AD bus, that is a multiplexed bus, has address in the first clock of the first machine cycle, T1. During the T1, the microprocessor sends the 16-bit address and the AD bus is having the address. AD7 to AD0 address is latched in the external latch when ALE is 1. AD bus now can carry the data. After T1 state, the AD cycle, that is a multiplexed bus, can carry the data now. In T2, the read control signal becomes low to enable the memory for read operation. The memory places opcode on the AD bus. The data is placed in the data register DR and then it's transferred to the instruction register. During T3, the read signal becomes high and memory is disabled. During T4, the opcode is sent for decoding and decoded in the T4. The execution is also completed in T4 if the instruction is a single byte. Yes. More machine cycles are essential for 2 to 3 byte instructions. The first machine cycle M1 is meant for fetching the opcode. We have to remember this. The machine cycles M2 and M3 are required either read or write data or the address from the memory or the input-output devices. So these steps define the whole timing diagram. Let's see how they can be represented in the form of timing diagram. This is so opcode fetch machine timing diagram. So we can see during these 4 states, T1, T2, T3 and T4. So up to this is the opcode fetch machine cycle. We can see S1 and S0 are both 1. Input output oblique memory bar is set to 0 because memory has to be activated. A5 to A15, no sorry, A8 to A15. This is carrying the higher order address. During the T1 state, ALE is enabled, ALE is put high, and during this state, the lower order address is placed on the lower order address bus. After T1, that is during the T2, this ALE signal is disabled and now the lower order address multiplexed address data bus is available to carry the data here. and during this cycle the read operation should be activated, because the read operation is to be performed on the memory. In this way, the T4 states T1, T2, T3 and T4 shows the opcode fetch machine cycle. So here we can have another example. Explain the execution of MVI B, 05H stored at the locations indicated below. So this is the instruction MVI B, 05H. Here it's having 2 bytes of machine code. The first byte is stored at 1000H and another byte is stored at 1001H. So the first machine cycle is equal to opcode fetch and the second machine cycle is the memory read, because the data has to be read from the memory. So let's have a look on this timing diagram. Here S1 and S0 both are 1, because this is the opcode fetch machine cycle. Here S1 is 1 and S0 is 0 during the memory read machine cycle. Here also the memory is activated and here also the memory is activated. During the opcode fetch machine cycle, the higher order address is latched to the higher order address bus. Lower order address is latched to the lower order address bus only during the T1 state. After the T1 state, the multiplexed address and data bus is available for latching the data, for carrying the data. The lower order address is latched only during the ALE is high. Then after that it is disabled. During this portion, when the data is being carried by the bus, read operation is enabled, otherwise disabled. During the memory read operation, again higher order address is specified, is carried by the higher order address bus. Lower order address is latched during the T1 state and later it is carrying the data. Again during the part of the machine cycle when the data is being carried, memory read operation is activated. In this way it completes the opcode fetch machine cycle. These are the series of the operations, series of steps which I have already explained. So in this, how many T states we require? First instruction byte is opcode, the immediate data. So opcode fetch machine cycle and read immediate data. So this machine cycle consumes 4 T states and this machine cycle takes 3 T states, total 7 T states. So in this way we have to do the analysis. So today we studied all the basics of the machine cycles, instruction cycles and timing diagrams, and in the later lectures we will go through all the rest of the machine cycles which are the part of the basic instructions of 8085. Thank you so much.